right, we have two words, and they're little phrases that are actually pretty easy. The first one is rate of change. And it is exactly what it says it is. This is how one thing is changing compared to the other thing. I liked how I explained it last class. It's how much one changes compared to the other. How much one value is changing compared to the other. So we know, like with ratios and proportions, we have two values, like money and eggs, and we're comparing money and eggs. This is just how much is money changing compared to how much eggs are changing. All right. It's the same thing, but we're going to add the word constant in front of it. Constant rate of change, which is the whole lesson. It's basically this thing, and it's just saying that it's not changing. It's going to be the constant. So like every shirt is going to cost $6, or every egg is going to cost 28 cents. So I'm going to say consistent change. So nothing crazy. It's not going to randomly throw a number. It's just going to be the same every time. All right. This formula is very important. This is how we solve for constant rate of change. We're going to have the change in y values over the change in x values. Change in y over the change in x. Or like miles per hour. This is basically unit rate. It's basically the same thing. So we've already done this. We're just going to kind of go at it a little bit different and get the same answer. Now, you're going to have two types of tables. You may have a vertical table or a horizontal table. In a vertical table, x is on the left, y is on the right. In a horizontal table, x is on top, y is on bottom.
Does it have to be that way?
Yes, but you don't make the tables, they make the tables. So when you see a table, know that this one is supposed to be x and this one, because it's not going to say x and y, you just have to know. Now, who likes science?
Me.
Cool. When y'all do experiments and you have to graph stuff, you have something called an independent variable and a dependent variable, right? How do you know which is which?
You don't know what you know. To look at that.
Carly, what do you think?
One like depends on something.
Exactly.
The other doesn't.
How can you figure out which one is which?
It goes along. It says like without or.
Oh, a comparison.
I know. It's a comparison.
What do you think?
The dependent variable is the one that you leave alone, like you don't do nothing with it. Or the independent variable is the one that you leave alone.
Yeah, the independent variable is the one that you don't get to decide. Usually it's like time. You can't decide time. Time just happens. Go for it.
Dependent is the part of the experiment that responds to the change.
Mm-hmm.
And independent is the part of the experiment that causes.
Cool. So, like time, or like how much you're gonna buy. If like the shirt is $6, if I buy one shirt, it's $6. So the price is dependent on how many shirts I'm gonna buy. So the Y value is the dependent variable, and the X is independent. So to tie that into science, when you're talking about like your labs and stuff, like if you're tracking how much a plant grows, time, you can't decide. So that's on the x-axis. That's going to go across the bar. And then you're going to track how much does your plant grow over time. That's the y-axis. All right. So what you're going to do, this whole lesson is 2 steps. 2 steps. The first step, you're going to ask yourself, how much does each thing change? And that's just going to be from like one value to the next. How much does it change? Did it go up 10? Did it go up 20? And then step 2, you're going to write it as a ratio. Change in Y over change in X, and divide or reduce. Depending. Oh, thank you. We'll do one little example. I think this is going to be easier than you think it is. So if you have a little table, I'll keep it little, and you've got time versus distance, or miles, and I've got 1 and then 2, and I've got 6 and then 12. Step 1, how much does each thing change?
6 times 6.
Wait, hang on. Let me zoom out a little bit. So from 1 to 2, how much did that change? From here
Plus 1.
to here. Plus 1.
Time.
Or time, let's think plus 1. From 6 to 12, how much did it change?
Plus 1.
Plus 6. Now I heard somebody say times 6. Right? Somebody said it? So from 1 to 6, that's times 6. So the jump from here to here is times 6. But we're going to look at these. So if I go back up to my table, X is on the left, Y is on the right. So is the 6 X or Y? Because it's on the right, it goes on top. So that makes the 1 X. That goes on bottom. The 6 goes on top. The 1 goes on bottom. What's 6 divided by 1? That's the answer.
That's it?
That's it.